Okay, so here's an application of why the vertex is useful. Remember, the vertex of a parabola is always going to be the minimum point or the maximum point, depending on if the parabola opens upward or downward. Okay, so let's look at this problem where the height of a baseball is modeled by this quadratic function here. Okay, so let's analyze it for just a moment. Think about this quadratic function. Since this first number here is negative, that means the parabola will open downward, which means the vertex would be up here. The vertex would be the maximum point on the graph. Okay, so if you read the question carefully here, the question asks for the value of x where the ball reaches its highest point. Well, the ball reaches its highest point at the vertex. So what we're looking for is the x-coordinate of the vertex, right? That's what we're asked to find then. So the x-coordinate of the vertex is what the question is. All right. You can read the problem more carefully if you like. I don't need to read it to you. And so, you know, this function is not in the very nice form where you can just tell what the vertex is. However, we do have a vertex formula which allows us to figure out the vertex without completing the square. And we know that the x-coordinate of the vertex is negative b over 2a. So we have our a, our b, and our c. Using a calculator, you can see that negative b without a calculator is negative 0.577. And on bottom we have 2 times negative 0.011. And using a calculator, you can see that this value looks like approximately 26 feet. It says round to the nearest foot, so I'll say 26, and that would be in feet because the height of the ball is measured in feet, and x is the horizontal position measured in feet again. So the x value is in feet. So the answer is when the baseball is 26 feet away from where it's thrown, right? The baseball makes a shape sort of like this. Its highest point is right here. That means this distance from where it's thrown is 26 feet. It takes 26 feet away to reach the highest point. Okay, let's try to answer part B of this question now. So now they ask for the maximum height of the ball. They don't tell you if you need x or y, but if you go back to the problem, the height of the ball can be approximated by this function. So that means the height is the function itself, which is y. So now this question is literally asking what the y-coordinate of the vertex is. That's what it's asking for, because the vertex is the maximum, so we want to know the maximum height, and that's the y-coordinate in the vertex. Well, we already know that the y-coordinate of the vertex would be the function which is called y as well, and we plug in the 26, which was the x value we found. So you plug 26 in everywhere you see an x, and you have negative 0.011 times 26 squared plus 0.577 times 26 plus 5. Put that into your calculator and round it to the nearest tenth of a foot. And it looks like to the nearest tenth you get something like 12.6. And y, again, the height is measured in feet, so I can say 12.6 feet. So again, the baseball is thrown, it makes a shape like this. It reaches its maximum point right here. The distance from where it's thrown is 26 feet. The actual height of the ball at its highest point is 12.6 feet. Okay? So that's an application of the vertex where you can see how the formula would be useful. You would not want to complete the square with all these decimals floating around. You'd rather just plug them into your calculator and the formula to figure it out. The other thing is that the vertex is always going to be a maximum or minimum, so the vertex can always help you in a word problem with a quadratic function because it can help you to find the maximum or minimum values.